So just three or four topics. One is allotropes, another one halides, another one oxides and oxyacids. We have only four topics. So in this, let us start allotropes. What is allotrope? Allotrope is the property of an element exists in more than one form. So the property of an element exists in more than one form. Exists in more than one form. That is called allotrope. For example, if you take phosphorus, more number of allotropes shown by element in 15th group elements is phosphorus. So phosphorus show three types of allotropes mainly: white phosphorus, next red phosphorus, and black phosphorus. The main allotropes of phosphorus are white phosphorus, red phosphorus, and black phosphorus. Here, allotropes are having different chemical properties. So, allotropes have different chemical properties. Allotropes have different chemical properties. Next, among these, allotropes of phosphorus are important. Those allotropes of phosphorus are only given in our NCERT textbook. In this chapter, we are going to discuss allotropes of phosphorus only. And remember, in this group, except bismuth, remaining all the elements show allotropes. So, bismuth does not show allotropes. In this group, bismuth does not show allotropes. Remaining elements show allotropes: nitrogen, phosphorus, arsenic, antimony, bismuth. They all show allotropic forms, but in those, more number of allotropic forms are shown by the phosphorus, and also according to our portion, we have only allotropes of phosphorus only. So what type of allotropes formed by phosphorus? White phosphorus, red phosphorus, black phosphorus. The allotropes formed by the phosphorus: white phosphorus, red phosphorus, and black phosphorus. Among these three allotropes, more reactive allotrope is white phosphorus. So let us write order of reactivity. Order of reactivity of allotropes of phosphorus. Nothing but white, next red, and last black. So order is reverse to the stability. So stability is more for black and reactivity is more for white. Now white phosphorus is more reactive. Now we are going to study one by one: white, red, black. White, red, black. First, white phosphorus. One by one we will see the points. White phosphorus. So it is more reactive than other forms, other allotropic forms. Why it is more reactive than other allotropic forms? The reason for that, white phosphorus exists in the form of P4. nothing but it consists of 4 phosphorus. Those phosphorus are arranged tetrahedrally, each phosphorus linked with 3 other phosphorus by using covalent bonds. And each phosphorus contains one lone pair, and hybridization of phosphorus is sp3, and the bond angle is here 60 degrees. So the bond angle is very less. When the bond angle is less, then there will be repulsions between bond pair in the cyclic ring. So that the repulsions between the bond pair in the cyclic ring, we call it as ring strain. We call it as ring strain. Due to ring strain, P4 is more reactive. Remember, if any ring strain is there in that cyclic compound, that compound is more reactive. If the bond angle is less, then internal strain will be more. If internal strain is more, then the compound is more reactive. So because of this reason, white phosphorus is more reactive. The reason for that, it is due to ring strain. Next, white phosphorus is, next point, white phosphorus is white translucent waxy solid. It is a translucent waxy solid. White phosphorus is white translucent waxy solid. Next, it is poisonous. It is poisonous. And third one, it is insoluble. It is insoluble in water, but soluble in carbon disulfide. It is insoluble in water, but soluble in carbon disulfide. And the next point, it glow in dark. It glow in dark. That property we called it as chemiluminescence. That property we called chemiluminescence. So it glow in dark. That property is nothing but chemiluminescence. Next property, it dissolves in NaOH. Next property, it dissolves in NaOH at inert atmosphere. At inert atmosphere to give pH3. This is called phosphine. Next, we are going to study the preparation of phosphine. So there also the same method we are using for preparation of phosphine. So how phosphine is prepared? Phosphine is prepared by dissolving white phosphorus in NaOH at inert atmosphere. So let us take phosphorus P4. It dissolves in NaOH. It means dilute NaOH. Then water also there, and then it gives 4 moles. 4 moles of pH3 is, and along with 3 moles of NaH2PO2. If H3PO2, it is called hypophosphorus acid. Here it is, here sodium is there, so it is a salt. So it is a salt. It is called sodium hypophosphite. If hydrogen is there, it is called hypophosphorus acid. So it is called salt sodium hypophosphite. It is sodium hypophosphite. This is the way of preparation of phosphine. So, white phosphorus dissolved in NaOH at inert atmosphere and it gives phosphine, and phosphine is a poisonous gas. Next point. It readily catches fire. It readily catches fire in air to give white dense fumes of P4O10, phosphorus pentoxide is formed. So it reacts when it is exposed to air. In presence of air, it catches fire and it forms phosphorus pentoxide. The phosphorus pentoxide produces white dense fumes. It is also called yellow phosphorus. Other name for white phosphorus, it is also called yellow phosphorus. Why it is called yellow phosphorus? Because when exposed to air, it becomes yellow. When exposed to air, it becomes yellow. Because of that reason, it is also called yellow phosphorus. Next, it consists of next point. It consists of discrete tetrahedral P4 units. That P4 units are nothing but like this. This is one P4. This is another P4. It consists of discrete tetrahedral P4 units. In between these P4, this P4 tetrahedral unit, and it is another P4 tetrahedral unit. In between, weak van der Waals forces are there. Weak van der Waals forces are there. Next one. Next, this phosphorus is subjected to combustion in limited supply of air. Next, when phosphorus is subjected to combustion, in limited supply, of air, then what happens is phosphorus plus O2 gives rise to P4O6. Then we can take 3 moles. Phosphorus trioxide is formed. P2O3 actually it exists in the form of dimer. We can write P4O6. So we call it as phosphorus trioxide. So the structure of phosphorus trioxide, structure of P4O6. First write 4 phosphorus tetrahedrally. Four phosphorus tetrahedrally. This is not a bond. just a tetrahedral shape. So after that, in between each phosphorus, put one oxygen. In between each phosphorus, put one oxygen. So each phosphorus contain one lone pair, and each oxygen contain two lone pairs. Each oxygen contain two lone pairs. Now in this case, how many POP bonds are there? So this is one POP, one, this is two, this is a three, this is a four, this is a five, this is a six. So in this molecule, 6 POP bonds are there. And no PP bond. In this case, there is no PP bond. In between phosphorus, there was no direct bond. So that is the structure of P4O6. In this, each phosphorus is surrounded with 3 oxygens. So we can write each phosphorus is surrounded with 3 oxygens. Each phosphorus is surrounded with 3 oxygens. Next, if the phosphorus is subjected to combustion in excess of oxygen. Next point, if phosphorus is subjected to combustion in excess of oxygen, then what happens is P4, now 5 oxygens are involved, then we will get P4O10. Now we will get P4O10, phosphorus pentoxide. Phosphorus pentoxide, actually P2O5, it exists in the form of dimer, so we will write P4O10. So P2O5 or P4O10 is a very good dehydrating agent. It is a good dehydrating agent. Dehydrating agent is nothing but used to remove water. Important reagent for organic. During organic conversions, we use P4O10 or P2O5 as a dehydrating agent. So the structure of P4O10 is similar to P4O6. In this case, what happened is at each phosphorus, one double bond is there. Each phosphorus, one double bond is there. In this case also, the number of POP bonds, number of POP bonds again 6. And also there is no PP bond, and each phosphorus surrounded with 4 oxygen, not 3 oxygen, here 4 oxygen. Each phosphorus is surrounded with 4 oxygens. Next, when P4O6 is subjected to hydrolysis, important, P4O6 is subjected to hydrolysis, then we will get 4 phosphorus are there, 4 moles of H3PO3. So H3PO3, here 4 into 3, 12 hydrogens are there, you can take 6 H2O. So P4O6 is called sorry, H3PO3. H3PO3 we called it as anhydride of P4O6, right? So in this H3PO3, if you take 4 moles from this, if you remove 6 water molecules, then you will get P4O6. So P4O6 is anhydride of H3PO3. So P4O6 is anhydride of H3PO3. Similarly, if P4O10 is subjected to hydrolysis, then you will get 4 moles of H3PO4. Here also 6 moles. So from this H3PO4, if you remove water molecule, then you will get P4O10. So P4O10 is anhydride of H3PO4. These are called oxy acids. In next coming classes, we'll discuss about those oxy acids of phosphorus. So that is about white phosphorus. Next, red phosphorus. Next, red phosphorus. How red phosphorus is obtained? How red phosphorus is obtained? First point, when white phosphorus is heated to 573 kelvins, then we will get a red phosphorus. When white phosphorus is heated at 573 kelvins in an inert atmosphere, we will get the red phosphorus. When this red phosphorus heating, we will get the black phosphorus. When red phosphorus is subjected to heating, we will get black phosphorus. Red phosphorus possesses iron gray luster. Second, red phosphorus possesses iron gray luster. Say. No, not mention particular temperature here. Next we will see how black phosphorus is prepared. Simply heating. White phosphorus is this is iron gray luster, but the white phosphorus is waxy solid. That is white waxy solid, and it is odorless. In notes it is given colorless. So colorless is wrong. Change it please. Odorless. It is odorless. It is non-poisonous. It is non-poisonous. But whereas the white phosphorus is poisonous, it is non-poisonous and insoluble in both water and carbon disulfide. Insoluble in water and carbon disulfide. Whereas the white phosphorus is soluble in carbon disulfide and insoluble in water. So tomorrow homework is you have to write the differences between red phosphorus and white phosphorus. Based on whatever the points we are discussing now, based on that you write the differences between red and white phosphorus. Next point. It is chemically less reactive. It is chemically less reactive than white phosphorus. It is chemically less reactive than white phosphorus. It does not glow in air. It does not glow in dark, sorry. But whereas white phosphorus glow in dark, that is called chemiluminescence. It does not glow in dark. That one glow in dark. It exists in the polymeric. It exists in polymeric tetrahedral tetrahedral P4 units joined together by covalent bond. Nothing but P4 units are joined together with covalent bond. In case of white phosphorus, discrete P4 molecules are there. Nothing but like this. This is white phosphorus and another white phosphorus. This is another white phosphorus. This is another white phosphorus. In between white phosphorus, there will be weak van der Waals forces. But here what happens is, in between these red phosphorus, there will be a covalent bond is there. So they exist in the polymeric form. Polymeric means they form long chains. In between polymeric chains, there will be covalent bonds are there. That is about red phosphorus. Next one, black phosphorus. Next one, black phosphorus. So black phosphorus has two forms. It exists in two forms. One is alpha black phosphorus. Another one is beta black phosphorus. So it exists in two forms. One is alpha black phosphorus and beta black phosphorus. Alpha black phosphorus is obtained when red phosphorus is heated to 800 kelvins. Then we will get alpha black phosphorus. When red phosphorus is heated to 800 kelvins in a sealed tube, we will get alpha black phosphorus. Next, this black phosphorus has sublimating nature. Sublimating nature. We know what is sublimating nature. Sublimation is nothing but conversion of solid directly into vapor without liquid state. And it is opaque and exists in the form of monohydric or rhombohedral. It is black phosphorus, alpha black phosphorus, it is opaque and exists in the form of rhombohedral. It exists in the form of rhombohedral. Or another form is there, that is nothing but monoclinic. Monoclinic, rhombohedral, etc. All these are different types of crystal forms. Next, it does not undergo oxidation in air. So because it is chemically inert, so it does not oxidize air. It does not oxidize by air. And beta black phosphorus is prepared by heating white phosphorus at 473 Kelvin. If you take white phosphorus, when it is heated at 473 kelvins, then we will get beta black. How alpha phosphorus is obtained? Alpha phosphorus is obtained by heating red phosphorus at 800 kelvins. Beta black phosphorus is obtained when heating white phosphorus at 473 kelvins at high pressure. Then we will get black phosphorus. It does not burn in air up to 673. So it does not burn in air up to 673 Kelvin. Above 673 kelvins, it can burn in air. So that is about different types of allotropic forms of phosphorus. That is about different types of allotropic forms of phosphorus. In the next class, we will see about the preparation of phosphine and phosphorus halides and also oxygen.